So exam one review, question 10. Question 10, it's a limit question. So let me open it up. It says, well, find the limit of this function that has x squared plus y squared minus 2x minus 2y divided by x squared plus y squared minus 2x plus 2y plus 2 as x and y approaches 1 and negative 1. 1 and minus 1. So our very first attempt is to do the substitution. Let's substitute these numbers. So here you get 1 plus 1 minus 2 plus 2 divided by 1 plus 1 minus 2 minus 2 plus 2. So on the numerator, I end up with, let me see, 2. On the denominator, I end up with 0. 2 divided by 0 is infinity. We don't say the limit is infinity. We just say the limit doesn't exist. The limit goes to infinity, does not exist. So question 24 says, find points on this function z equals to 3x squared minus 4y squared, at which the vector n, you have a vector like n, this vector has components 3, 2, 2, is normal to the tangent plane, is normal to the tangent plane. So suppose you have a surface, this is your surface, and you want to find the points on the graph. So x sub 0, y sub 0, z sub 0, such that when you have your tangent plane, this is your tangent plane, let's use a different color for tangent plane. Tangent plane at this point, and the normal vector and the vector n, don't have any other color left. Yeah. Oh, this one is cool. This is your vector n. They are orthogonal to each other. They're perpendicular to each other. So when you have a tangent plane, this plane definitely has a normal vector. The normal vector for tangent plane is parallel to the normal to this vector n. Now, how do we find these points? So, equation of tangent plane, it is z minus z sub 0 equals to f of x, x minus x sub 0 plus f of y. So let me just write this. I already know that how to calculate this, times y minus y sub 0. So we're looking for these components, x sub 0, y sub 0, and z sub 0. Okay, so these are, for example, missing values for us. Z minus z sub 0 is equal to partial derivative of f with respect to x, 6x, times x minus x sub 0 plus f of y, which is negative 8y, and y minus y sub 0. So very well, if we need to calculate this at x sub 0 and y sub 0. So these are just numbers for us. At the same time, when you write equation of a plane in general, equation of a plane has this formula. You have a times x minus x sub 0 plus b times y minus y sub 0 plus c times z minus z sub 0 equal to 0. This is what you learned from 1c. And n, or the normal vector, is a, b, and c. So what you're going to do, you're going to rewrite this equation in this format. And the normal vector for your plane is parallel to this vector. This is n, and then this is your normal vector for the plane. Well, question 7 says, find the limit of this function. Limit of xy minus 2y divided by x squared plus y squared minus 4x plus 4. And now your point is approaching to 2 and 0. It's not like before. It's not like 0 and 0. It's not like the origin. So remember that to find the limit of a multivariable function, we have different techniques. We can use a general path that passes through that point. So when you're writing a general path, it's not going to be y equals to mx. This line, set of lines, it doesn't pass through 2 and 0. It must be y equals to m times x minus 2. So you cannot use this path. This path passes through the origin. It doesn't pass through 2 and 0. So you either use a general path, or sometimes we're lucky, we use some specific paths and we get different numbers for our limit, and we say that the limit doesn't exist. In this case, it's easy to say that, hey, y is equal to 0 as one of the paths, and another one, y is equal to, I'm setting m equals to 1, x minus 2. Just 2 paths. Some specific paths. Or you can use squeeze theorem. Or you might say, hey, let us use parametrization. Sometimes it works. Well, if you use some specific paths like this, you can quickly see you have different limits here. So the limit of xy minus 2y divided by x squared plus y squared minus 4x plus 4 as x goes to 2, y goes to 0. If y is equal to 0, this guy becomes 0 divided by x squared minus 4x plus 4, which is equal to 0. Because your numerator is 0, 0 divided by the quantity is equal to 0. If you use the second specific path, like y equals to x minus 2, you get xy minus 2y divided by x squared plus y squared minus 4x plus 4 as y goes to x minus 2. Then we send x goes to 2. This is equal to the limit of, so let's see what we have here. This is x times x minus 2 minus 2 times x minus 2 divided by x squared plus x minus 2 squared minus 4x plus 4 as x goes to 2. So if we simplify this guy here, so let me see what's the simplification. Can we get rid of some of the terms here or not? So here you have x squared minus 4x plus 4 divided by, eventually we'll find the limit, divided by, here you get x squared, 2x squared, then you have minus 4x minus 8x, and here you get plus 8. So here x goes to 2. Here if you factor out 2, it's going to be 1 divided by 2. So you have a half, you have 0. They are different from each other. Different limits. So it means that it does not exist. Okay, question 16. Well, question 16 says, is the following function a continuous function? And the function is defined as a piecewise defined function. This is f of x and y, which is equal to, it says, inside a disk, so x squared plus y squared less than 1, inside the unit disk, we have this definition for the function, x squared plus y squared. And on the boundary and outside the disk, the function is a constant function 1. X squared plus y squared greater than or equals to 1. The function is a constant function. Z is constant. Is this continuous? First of all, you need to check the domain of the function. And if the point belongs to the domain, then we need to find the limit of the function. Does the limit exist? Find the limit. And the third condition is the limit is equal to the z value of the function. Limit is the same as output value. Okay, first of all, since I have a disk and my function is x squared plus y squared, it's easier for me to use parametrization to rewrite this function. Let us use parametrization to rewrite the function. Okay, perfect. So x is r cosine theta, y is r sine theta. So f of r cosine theta, r sine theta, or in general, we write f of r and theta. So let's rewrite this guy this way. So f of r comma theta is equal to r squared cosine squared plus r squared sine squared is going to be just r squared. When r is less than 1. And when r is greater than equals to 1, this is going to be 1. I simplified my function to only one variable. It makes life much more easier for me to check the continuity of the function. Well, when r is less than 1, r is greater than equals to 1. The boundary number is 1. The only troubling number is the boundary number, which is 1. The only troubling number is the boundary number. It's always true when you have piecewise defined function. The boundary number, which is 1 in this case, is the troubling number. It's the only number that you have to be careful about. So since 1 belongs to the domain of the function, we're fine with the first condition. 1 is in the domain. Why is that? Because we see equality here. So 1 belongs to the domain of the function. R is greater than or equals to 1. 1 is included in the domain. 2, find the limit of the function. Well, limit of the function r squared as r approaches to 1 from the left-hand side. This is just a term raised to the second power. It's a nice term. By substitution, it is equal to 1. The limit of the function while r approaches to 1 from right is defined as a constant function 1, which is equal to the limit of 1 as r approaches to 1 from right side. So the limit exists. The limit exists and it is 1. The third condition, the limit 1 must be equal to the value, output value of the function at 1. At r equals to 1, the function is 1. So the limit is equal to output value of the function. 3 conditions are met and the function is continuous. Okay. Question 15. A fun question to work with. So question 15 says, use the squeeze theorem to find the limit of this function. We want to find the limit of x squared minus 16 times cosine of 1 divided by x minus 4 squared plus y squared as x approaches to 4 and y approaches to 0. Okay. First of all, you have cosine function. Get back to pre-calc. Cosine function is always bounded between -1 and 1. This is the graph of cosine. This is what we learned about cosine. The function oscillates between -1 and 1. So you can just sandwich cosine between -1 and 1. Well, now I can multiply all sides by x squared minus 16. Multiply all sides by x squared minus 16. This guy, you can easily find the limit. So we have -1 times x squared minus 16, and the middle function is x squared minus 16 times cosine of the quantity that you have, and here you have x squared minus 16. Now, take the limit. This is your function on the left. This is your function on the right. If their limits are the same, while x approaches to 4, y approaches to 0, then the limit of the middle function is also the same. So the limit of negative x squared minus 16, I don't have any y. I'm not worried about y. While x goes to 4 is 0, which is the same as the limit of x squared minus 16 as x approaches 4. The limit from left and the limit from right, both of them are equal to 0. So the limit of this function is also 0 by squeeze theorem. So for 17, that is about the limit. This is similar to what we did in our quiz. About the limit. So it says find the limit of 3 to the x minus 1 divided by x times sine y over y, if I'm not mistaken, as x approaches 0, y approaches 0. So if you plug in 0 and 0, you get 0 divided by 0 times 0 divided by 0. This is our very first step. We get indeterminate form. So what are we going to do? We're going to treat this separately, treat this guy separately, and find the limit of each of them separately and multiply them together. So the limit of 3 to the x minus 1 divided by x as x approaches 0 is 0 divided by 0. We're using L'Hopital's rule. This is going to be ln of 3 times 3 to the x divided by 1, and then the limit as x approaches 0 is, we just substitute 0 here, we get ln of 3. Now the limit of sine y over y as y goes to 0. 0 divided by 0, applying L'Hopital's rule, we get the limit of cosine y divided by 1 as y approaches 0, which is cosine of 0 equals to 1. So this is equal to ln of 3 times 1 or ln of 3.